Okay, question 11. Solve algebraically the system of equations. Okay, so fancy way of saying work out what x and y is. Algebraically just means we can't guess. Okay, so what's x and what's y? Now, first of all, I think it's quite interesting to know what we're doing when we solve simultaneous equations. Okay, if you think of your x and y, obviously it's a wee bit wobbly. I don't know what's going on. What we're actually saying is if you've got a line, okay, that's one line, and then say we've got another line, you're working out the intersection point between those two lines, because what we've actually got here, if you rearrange these equations, is the equation of a straight line. Yeah, we've got y and x, and we've got a number. Okay, so we can rearrange that to be y is equal to mx plus c. So sometimes this question is dressed up with a find the intersection point. Okay, that's all we're doing because this equation and this equation, they've got so many different x and y's, loads and loads. Okay, infinite number of x and y's. But at one point, the x and y will actually be the same for both of them. Okay, and that's this point here. Okay, so I think that's interesting. Not everyone realizes what we're doing when we solve this. Okay, and again they've tried to dress up, mathematically the system of equations, but find x and y, find where these two lines intersect. So the first thing you want to do is we've got two variables, so we want to get it down to one variable. All right, I can't solve that right now, and I can only sort one variable is all I can solve. All right, so I need to get rid of an x, or I need to get rid of a y. Now the easiest thing to do is just to multiply by the opposite coefficients. Now what I mean by that is say, okay, well I've got 3x and 2y, so I'm going to times this by 2 and times this by 3. Okay, so by doing that, I would get 6x plus 4y is equal to 34, and I get 6x plus 15y is equal to 12. Okay, now you can see there, because I've multiplied by those two numbers, I've got 6x and 6x. I can now take this equation away from this equation or vice versa, and that'll cancel the x's out. Okay, I also could have done, instead of looking at the x term, I could look at the y term. I could have said, okay, well I've got 3x plus 2y is equal to 17, and I've got 2x plus 5y is equal to 4. So I could times this one by 5 and times this one by 2. So that would give me 15x. Yeah, sorry, I just thought I'd done something wrong there. 15x plus 10y is equal to 85. Okay, and that'll give me 4x plus 10y is equal to 8. So these are the two ways I could have done it. All right. So you just times them by the opposite coefficient. Okay. Now, if you fancy yourself as a a smart person, and if you're really clever, in this case I can't actually see a way of doing it, but sometimes it's easier to find a common coefficient. Okay, so instead of this is obviously the easiest way and it works for every case, but sometimes there's a intermediate coefficient that will just save you a wee bit of arithmetic. Okay, so I'm trying to give an example. If you ended up with I don't know, 3 and 3x and 9x, okay, plus 2y plus 8y, 5 and 10. I could obviously say, okay, well, I'll take this equation, I'll times it by 9, and I'll take this equation and times it by 3. You could do that. But you could also say, well, look, I know 3x times 3 gives me 9. So I'm actually going to just leave this equation as it is, and I'm just going to times this first equation by 3 to get the 9x. Okay, so you can do it that way as well, but this way is always going to work by timesing by the opposite coefficient. Okay, so yeah, I'm just going to work through with this one. Okay, I'm going to go through with that one. Okay, I'm just going to leave this, but that was just an example of what you could do. Okay? So I'm going to call this equation 1, call this equation 2, and I'm going to do equation 1 take away 2. Okay, so I'm going to get 0 for the x's, okay, so 0, and then 4 minus 15 is going to give me minus 11y, which make that minus a little bit clearer. And 34 minus 12 is going to give me 22. Okay, I want to now move the 11 over to get y on its own. So how do I move a minus 11 times y over? Well, it's doing minus 11 times, so you do minus 11 divide. So I'm going to end up with 11 is equal to 22 divided by minus 11. So y is obviously equal to minus 2. Okay. 22 divided by 11 is 2, positive divided by minus is a minus. So that's our first step. Pretty straightforward, yeah. Manipulating the equation, do one away from the other. I could have done 2 minus 1 as well, I would have got the same answer. Okay. Next question, the next part is working out x. So how do I work out x? Well, you could almost do the exact same thing if you wanted. You could say, well, I'll get rid of my y's. You could work through this part of the equation here if you wanted. You could do that. But the easiest thing to do is just to substitute in your y number. Okay, so I'll take let's take this equation here. Okay, so I know that 2x plus 5y is going to equal 4, and I know what y is. I know that y is minus 2. Okay, so I've substituted in for y, and everything else just stays the same. So what does that give me? 2x minus 10 is equal to 4. Now we need to solve to get x on its own, so I need to move the minus 10 over, and then I need to move the 2 times over. Okay. So how do I get rid of minus 10? Well, of course, I add it. So it's going to be 4 plus 10. Okay, so 2x is equal to 4 plus 10. How do I get rid of the 2? Well, it's 2 times, so I'm going to divide it. Get x is equal to 4 plus 10, all divided by 2. 14 divided by 2 is 7. Okay, so pretty straightforward, I think, but there's a wee bit in it in terms of arranging and manipulating formulae. Okay, so for your marks for that one, what does it say? You get a mark for scaling, so we get a mark for this point here. We would then get a point for a strategy, so I think someone would look at this and say, yep, this is a valid strategy, 1 mark, and then you actually get a mark for calculating the correct values of x and y. So you can maybe imagine that you're getting a mark for scaling, and then a mark for x and a mark for y, something like that. Okay, but the actual marking scheme says evidence of scaling is 1 mark, and then following a valid strategy through to produce x and y. Okay, and then actually stating what x and y are. So I think that's a bit of an odd way to write it. I think I would have just given a mark for x and a mark for y. But yeah, it seems to be a mark to follow a valid strategy. That's what it says. I'm not a marker, so yeah, there's a bit of an art with that stuff, and it's something I'm not clued up on. So I'm just reading what it says. Question 12. Simplify. Okay, great. So this, we're looking at fractions. Okay, so we can cancel top and bottom. That should be right away when we think of a fraction and simplifying. We should be thinking, okay, well, something on the top is going to appear on the bottom, and I'm going to cancel them out. Okay, but how do we simplify these equations? Well, we're going to have to factorize them in some way. Okay, now there's about 5 different forms of factorizing. Okay, just see if I can notes here so I don't miss any. Yeah, okay, so the first one would just be our common factor. Okay, that's the most straightforward, just a common factor. Now I'm looking at this top one and I'm thinking that is a common factor, isn't it? Okay, so the top one is going to become x and x minus 4. Okay, so that's common factor. Now, that is the best place to start this question because, like I said, if we're thinking on reducing it down, if this is the bracket on top, chances are that bracket will be somewhere on the bottom. Okay. The other way of factorizing, we can be doing difference of 2 squares. So when we see difference of squares, so when we see something like x squared minus 9, okay, that is going to give us x plus 3, x minus 3. Okay, the key here is difference of squares. This number is going to be a negative square number. So we basically do the root of that number and then do an x plus 3, x minus 3. We do the plus the root and minus the root. Okay, so if we've got no x and we've just got a square number at the end, it's going to be difference of 2 squares. Okay, the other way is complete the square, which we talked about before. Okay, and that comes in the form, let's say, x plus 4 squared minus 20, something like that. Okay, but we would use this when we couldn't think of a way to normally factorize it. We can manipulate it this way, but that's the form for the complete the square method. Okay, so if we can't factorize it normally, it's usually a complete the square. Okay, The most normal one is just your standard trinomial. So if we have, as an example, say x squared minus x minus 6, our factors are going to be x something, something, and those somethings in here and here have to add to give us this coefficient and multiply to give us this. So add to give us minus 1 and multiply to give us minus 6. So in this case, that's going to be minus 3 plus 2 for this particular case. Okay, so add to give us minus 1, multiply to give us 6. This can be tricky for people because they can't always spot it. The best way to spot it is just to write down your factors of minus 6. Okay, so it's minus 6 and 1, yeah, minus 3 and 2, and then you're back to, you do minus what? Oh, sorry, minus 2 and 3, and then minus 1 and 6. Okay, so you got all your factors, and then you say, well, which one should these two numbers add together to give me this? Well, it's minus 3 and 2. So just write down your factors, take your time. You should come up with something. That's one. But the other method here, the trinomial, you can get the complicated method, all right? Where usually you get like a number in the front there, okay? And that's a little bit trickier for people to work out. So I'll call that method 5 actually. Right? It's the same idea as this, but it's a little bit trickier. And this is a little bit of trial and error, so conscious of time. Now I know what I'm going to have, so I'll do my table. I know I'm going to end up with 3x squared in here, and I'm going to get minus 10 in here. So then which two numbers are going to multiply to give me 3? Well, it's got to be 3. 3 and 1, doesn't it? So I'm going to have 3x and 1x. Okay, that's definite. And minus 10, well, what would give me minus 10? Minus 5 and 2 would give me that, okay? So you do that, and then you say, well, does that then work out correct? So that would give me minus 5x. That would give me 6x. Nah, that's not right. So if that's not right, switch them round. All right. So let's try minus 5 in here, plus 2 in there. That's going to give me 2x minus 15x. Oh, yep. Now all of a sudden this is giving me minus 13x. Okay. So this more difficult method is a little bit trial and error-ish. Okay, we know we're going to end up with 3. We know 3x squared and minus 10 on the table, so we can try and work out what these middle numbers are going to fall out as. Okay, so that would then give us 3x plus 2 and x minus 5. Okay, so those are different methods of doing it. Okay, so this one looks like a common factor method. This one down here is not going to be a difference of two squares. It's not going to be. It's not. Doesn't look like it'll be. Well, it could be a complete square. We don't know yet. But I think it's probably just going to be a simple trinomial. So let's just see if we get that. Okay. Now it's going to have to add to give us this and multiply to give us this. So what's our factors of minus 20? So minus 20 factors. So we'll start off with minus 20 and 1. Minus 10 and 2. No, minus 5 and 4. We're getting close. Minus 4 and 5. It's got to be that, doesn't it? Because 5 minus 4 gives us 1. Okay, so that's going to give me x plus 5 and x minus 4. Now again, did I even need to do that? Nope. Because on the top we get x minus 4. It'd be a good guess we're going to have an x minus 4 on the bottom as well, which I've just proven we've got. They cancel out. X divided by x plus 5. Okay, so look, I tried to rush through a bit of that, so I'm sorry if it was a wee bit quick. Marks for that one, mark for the top, mark for the bottom, mark for simplifying. Common factor does come up a lot, so make sure you know that, and that's the easiest one. Difference of two squares should be the easiest to spot. There's no x term. Okay, completed square is going to get used when you can't use your normal trinomial like these. Okay, and your normal trinomial that add to give you this coefficient, multiply to give you that. Just get used to working out your factors and then see which one adds. Okay, and the difficult one, when people see this, they think, "Oh, how do you do that?" Well, just take your time, bit of trial and error. Okay, you should know, you know what's going to be in here, you know what's going to be in here. That's this term and this term, and then you've just got to set up and guess what these two numbers are going to be, so that these work out correctly. Okay, so it's a little bit, all things a little bit trial and error. So yeah, practice. I think of all the questions so far, I would say that's probably the trickiest one, doing a bit of factorising, okay, because it requires just a wee bit of instinct and intuition. And I think because there's only one equation of a line, yeah, even here they told you we're doing the completing the square, but on this one you had to tell which form of factorising you're using. Okay, cool.